I wanted to bring the topic, contributing to the machine learning topic. I mean, I think what I've seen is there's a lot of research and development right now on artificial intelligence in the topic of estimating real-time well production. I've seen a lot of initiatives out there using information from downhole, using information from the surface, combining first principle models and better measurements that are being developed out there with machine learning in what's been called a hybrid model, and combining the best of both worlds to produce an even better solution, even better than the things we have seen before. Multi-phase flow metering is an old topic already. I mean, a lot of companies produce their own equipment. It's been around for a while, but I think machine learning and artificial intelligence research is getting a lot into this topic. And I think, Cesar, in the near future, we're going to see a lot of deployments of, the Holy Grail, essentially knowing with a certain degree of error, which is acceptable, how much each well is producing in oil, gas, and water, and possibly sand. That's like, if we can get to that point, can you imagine what the future looks like in terms of managing a well? Now you're talking about looking, as you said, looking beyond. What are the engineers going to look at the forecast? That's what's going to hit me next. What's going to hit me next week? It's not about today. Today it's under control. I've got the big picture, but it's really about the future. It's really exciting.
Well, it's quite interesting. In fact, I believe that the methods for measuring are going to be continuously evolving. Eventually, one day we will not see in the platforms, the typical volume separator, volume per volume, okay? Because the methodologies for measuring probably will evolve. You will have new technologies. Right now, there are already many other technologies different to just volumetric, okay? But the issue here is that despite of those improvements, I mean, the physical reality of let's say the nature itself, okay, of the reservoir and the way you produce those fluids is quite complex, okay? Every single reservoir is different. Every single well behaves, because as I said, the characteristic, the geologic characteristic of every reservoir might be different from one to another. That means that the only way to really take advantage of this Holy Grail, okay, that is basically just measuring, is that having an integrated, let's say, modeling capability to understand the behavior of the reservoir, the downhole area, the wellhead, the surface. Okay, you have to see that in an integrated fashion to be able to really do proper forecast to see what's going to happen. If you're not integrating all those things, you might have a proper measurement and a forecast that will just be valid just for a very short period of time. That means if you are measuring continuously the behavior of a well, and you have a trend of the last 3 months, eventually you can do a forecast, an extrapolation from that behavior, okay? But, I mean, it doesn't have anything to do with the physics that are really happening inside the reservoir, because eventually in the next 3 months, you will have a water encroachment problem. Eventually you are measuring, this water cut, and then suddenly it goes up. Why? Because you were in front of a water encroachment problem and you were not expecting that. Yeah. Okay, the measurement in a continuous fashion does not allow you to really do that kind of estimation. You need to integrate all the models. For sure, if you had the capability to measure how the reservoir is behaving itself downhole, eventually you might say, okay, only based on measurement, I will be able to make forecasts. But this is not the reality.
No.
The reality is that you are taking some information, real information, true information, and then you are creating models, okay? And this quantity, massive quantity of data is helping you really to do better, for example, history match, okay? To analyze how this variable behaves thanks to the impact of that other variable. At the end of the day, it's a correlation factor. You are correlating variables to others and then understanding and bringing this comprehension to the new model you're creating.
Yeah.
Okay, and this model integrated with all this data is the key. And definitely, I'm very sure that these new ways to measure fluids, pressure, temperature, etc., will enable doing more. I mean, getting more data at a lesser cost. Okay, and eventually this will be connected to other kind of tools, mathematical tools that will allow you to really visualize quadrants of where are the problems, and say, okay, these different variables are indicating me that the well has these sort of problems, or the reservoir has this sort of problem. So it will speed up the diagnosis, the troubleshooting, the anticipation, and making action to improve that process.